second and the third lessons change it up a little bit from last class. But what I'm going to try to show you is that what we did, hopefully you saw the relationship with what we did last class with rates was very much like what we did last unit in Unit 7 with velocities. What we're going to do here, very similar to a very specific type of problem we did last unit with velocities, okay? But it's going to take me a while to get there, so just stay with me. If I ask you to find an accumulation, say of x squared from 0 to 2, you have two options to get this answer. What is one option to get this answer, 0 to 2 of x squared? Tell your neighbors. What's the easy option? Yes, you could use your calculator to accumulate. All right, go ahead and type that into your calculators. Then you will not use your calculator for the remainder of the class period because we're going to go no calculator. Okay, what is the other way? Now your calculator's gone. No more calculator. No more calculator. Okay, calculator's gone. You know what the answer is going to be. But how do you get that answer without a calculator? Yo, nailed it. Math. No calculator, you take the antiderivative. Why is that the symbol for accumulation? Because for years and years and years, the only way we could accumulate is actually the way of the antiderivative. So you take the antiderivative, you got 1/3 x cubed plus c, you then plug in 2 and plug in 0 and you subtract them. You get 8/3 plus c minus 0 plus c, and you just get 8/3, and that's 2.666666. Okay? So remember, calculator accumulates. Without a calculator, we antiderive. Rod, put your phone away. Like away, not on a table, in a backpack, deep in that backpack. Okay. Is there a third way? We don't have our calculator. Here is f. I ask you to accumulate f from 0 to 3. And you're like, okay, I don't have my calculator, so I need big F. But it's like, I don't know what big F is. You didn't give me an equation. So what do I do? Tell your neighbors, what do you do if this is what F looks like? Yeah, you understand the visualization of accumulation ends up being like an area. You add up all the F's, so you just create this area of a geometric shape that you are familiar with. What is the shape and what is the area? What is the answer? Tell your neighbors. Do you remember the area of a triangle? Yeah, it's a good thing to write down if you don't remember. The area of a triangle is 1/2 base times height, and that is a base of 3 and a height of 1. You get 1.5 or 3. Okay? Geometry is a third way to find accumulations if we have straight lines. Okay? If we have straight lines. Now, remember how we had our velocity, and our velocity went underneath the x-axis. We said the accumulation was negative. Hopefully you remember how when your derivative was negative, you know your original function is decreasing, we said that the accumulation would be a negative value. If you have an accumulation of f from 0 to 4, first of all, you need to make sure you're finding all of the f's added up, which looks like an area, from the x-axis all the way to where f is. That's one thing. You got to make sure you go all the way. Second thing you have to remember is that when you're underneath the x-axis, we would have like a negative accumulation. We'd have like a negative area. So like this area right here, which would be a triangle base length of 1, I'd say the height is -2. And this would be an area of -1. It's not an area, it's an accumulation of -1. Here, this is a base of 2, height of 2. It's above the x-axis. It's an accumulation of these positive values. This positive 2. Now, what about this last part? Now, very important to realize you got to do all of it. You realize, oh, it's a trapezoid. I'll teach you the formula for the area of the trapezoid later, next unit. For right now, let's just call it a triangle on top of a rectangle. Easy to do, nothing crazy, nothing new really. So rectangle, it's really a square 1 by 1. I'd consider this -1 because it's underneath the x-axis, an accumulation of a negative value. And here, this would be -0.5. If I want to accumulate f from 0 to 4, add the positives, add the negatives, you could get an overall answer that is negative, and that's okay. Cool. Well, we won't just always have straight lines. Sometimes we will have curves, but they're going to be specific curves. For example, this is a quarter of a circle. You guys remember what the area of a circle was? Pi r squared is correct. Pi r squared. So triangles, 1/2 based on site. Rectangles and squares. Hopefully we don't have to write that down. Circles, pi r squared. So, quarter of a circle, a quarter of a pi r squared. Go ahead, tell me what the accumulation of f is from 0 to 3. Go. 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 Let's see if I can catch you on any mistakes. Close, and I like what you're doing. The quarter circle actually ends right here. The quarter circle actually ends right there.
Oh wait, you don't find it.
All right, now. We gotta move on. Here's mistakes that students make. They say, oh yeah, this is pi. And they say, oh yeah, this is 1/2. And you say pi plus 1/2. And it's like, no, you forgot. There's more. There's more. We need to accumulate this f, which means we need the entire area. We need everything from the x-axis up or down. So we don't just have the pi, we have the pi and this rectangle of 2. We don't just have this 0.5, we have this 0.5 and the 1. We get 3.5 plus pi. Okay, so make sure you know when you're accumulating the function, you're accumulating its like values, its heights. We're going from the x-axis. Don't forget the stuff underneath your shape. All right, now, we are comfortable with saying now that accumulations above the x-axis result in positive values. Accumulations below the x-axis results in negative values. But there's been one thing that we really haven't paid attention to that actually could have been different and could have changed our results. Lock in, people, please. This and this are boundaries. Did you know that the order matters? Go ahead, break out that calculator again. Flip the boundary. Go to 0. Now, we've always gone from a smaller value to a larger value. We've always gone from left to right. But it is possible, team, to go in the opposite direction, to start at a bigger value and go backwards. But you guys have already been doing it. You just don't realize you have been. Many of you could have told me that it probably is going to be the opposite. But let's just kind of get one example that you're familiar with. Let's say f prime is positive, it's a velocity. Let's say I know f of 2 is 5. Let's say I ask you to find f of 0, and you know that the accumulation of f prime from 0 to 2 was 7. What is f of 0, and how did you do it? You subtracted, going backwards. You took 5 and subtracted 7 to get -2. You should be cool with this expression. But now, what I'm telling you is that is the exact same as this expression. Plus, instead of minus, but accumulate going back in time. 2 to 0. Adding 2 to 0 is the same as subtracting 0 to 2. Or, you go backwards, the same as the opposite of going forward. And you're comfortable with this, and this is what you did last year. Great. One more thing. What if I accumulate, but my start and end are at the same spot? What do you think? What do you think we get? If you say 0, great. If you said like the F at that point, I understand why you're saying that. But here's the thing. Think of this as like being tied. How much time has elapsed? No time. So how much did you accumulate? Nothing. There hasn't been any time to allow me to accumulate anything. So 0. Okay. Now I'm going to introduce to something that looks very new. And you're going to be intimidated at first, but I'm going to show you pretty quickly that what we're about to do, we've already done. It's just going to look a little bit different. I'm going to introduce you to something called an accumulation function. And here's an accumulation function. It's an integral that has a variable as a boundary. You can read this as accumulate, whatever we're talking about, from starting point A till wherever we decide to end at x, where x is a variable, a is a number. Cool? Cool. Here's our first example of accumulation function. Typically, you see an accumulation function of something equal to something else, okay? That way we can kind of just like ask specific questions, find g of 4, g of 7, g of 2, g. Now the first thing that confuses students, Brown, is why the heck do we have x's and t's? What is going on? What is going on with that and that? And what I'm going to try to tell you is that it's just a necessary thing. This x is the important thing. Whatever this is, I don't really care. You could erase it, pretend it wasn't even there, and everything should make sense to you. If it wasn't there, I don't know what just happened. I think somebody's hacking me. What went on the screen just now? Did anybody see that? Was it AT&T coming back online? Oh, geez.
What? No. Your computer doesn't have data.
Because you have a suspicious look on your face. Oh.
I don't think you did that.
Nothing. I don't think it does.
He leaned back.
Yeah. All right. So, guys, if it's just this, I bet you're going to be fine with what you're going to do. Now, don't even care what's here. But let's pay attention to what is this the graph of? It's the graph of F. Guys, this is the graph of F. This is not the graph of G. This is the graph of F. Okay. Now let's just do a couple of these problems. See if you pick up where I'm going. What's G of 4? If you say 0, you're on top of things. 4 is replacing X. So it's like G of X. So that means I want to take this X and replace it with 4. So I'm finding the accumulation from 4 to 4 of F. Again, don't worry about the T. It's like a necessary thing so that we're accumulating F and we don't have variables that match. So if we removed it and we just said accumulate F from 4 to 4, you guys are cool with 0, right? Okay, well, that means G of 7 would be the accumulation from 4 to 7, 7 replacing X of F. All right, what is that? Tell your neighbors, find it out. Not 3. Not negative 2. No. No, it's not negative 2. No. Negative 1 is correct. Negative 1 is correct, Stool. You were wrong. Okay. You go to your graph and you're like, oh, I'm starting at 4. I'm accumulating F from 4 to 7. If you want to do the visualization, boom, there's the accumulation. It creates an area. We realize we don't need a calculator. We don't need antiderivatives. We can find the area geometrically. We got a 1/2 base of 1 height of 2, so this is going to be 1. We got a 1/2 base of 2 height of negative 2, and that's negative 2. Add them together, you get negative 1. Now, I'm going to do G of 2. You're going to do G of 0 if you haven't done it already. If I were to plug in 2 for X, I'd go from 4 to 2 of F. Here is my large hint. Just take the opposite of 2 to 4 of F. What I would do is say 2 to 4, this area above the x-axis, rectangle base 2, height 2, is 4. But if I'm going from 4 to 2, I take the opposite. I subtract that number. I get negative 4. Okay? I do not write this value in here as negative 4. Fish, I'm calling on you for G of 0, and you're going to tell me what it is. Okay? Everybody find G of 0, and Fish is going to tell us the answer. Give him the wrong answer.
Explain it. You should explain it.
Yo, I hope we're all getting the answer right now. Fish, what's the answer? All right, great. Whoa. I want to go and accumulate F from 4 to 0. I will do the opposite of 0 to 4. I'm going back in time. I'm subtracting just like you did last unit. 4, 5, 6, 7, but -7. Now, I'm about to show you something. And you should be like, oh yeah, that makes sense. Stop doing that. Nice. G of 0 was -7. G of 2 was -4. How do I get from -7 to -4? We add 3. Oh, I add 3. G of 4 was 0. How do I get from -4 to 0? I add 4. G, I could probably include 5 or whatever. G of 7, I found, was -1. How do I get from 0 to -1? Overall, I subtract 1. What does this mean? What does this mean? This is a graph of something. The graph of F. But guess what F is equal to? Anybody? Yo! Did you guys really say that right off the bat? Because that's great. What is G prime? G prime is F. Now this is where a lot of people have confusion. Because you see this. You got X's and you got T's. And if I say, guys, take the derivative of this. The derivative of the left side, G prime. Cool. The derivative of the right side, I see a lot of people do a lot of things. I see a lot of people say, oh, it's got to be the integral. This has got to be F prime in here. That's got to be F prime. No, that's not right. That's not right. What did Newton discover? Why is this the symbol for accumulation? Because accumulations and antiderivatives go hand in hand. That says antiderivative. They go hand in hand, which means if you take a derivative of an accumulation, it's like taking a derivative of an antiderivative. You're just going to get rid of the integral. This is important, guys. If you take a derivative of an integral, they cancel each other out. You take a derivative of an integral. It's like, all right, well, nothing happens. You took the antiderivative, you take the derivative, boom, back where you started. Turns out this graph of F was a graph of a derivative the entire time. This was a graph of a derivative whose signs were positive. They changed signs at 5 and then negative. Whose accumulations were actually accumulations of the derivative. The accumulations of F are the same as the accumulations of G's derivative. And everything fits like we expect it to, like we saw last unit. What we're about to do is the question number 1 from your test. Here is the graph of V. Here are the accumulations. The only difference is that is a graph of V. You find the accumulations using geometry. And everything else falls. Okay? Now, the one thing is that you have to make the connection. You have to make the connection that the derivative of G is just the graph that's given to us. You have to have this established and written down. A lot of people won't because you are horrible at labeling your things. G prime equals F if that changes sign. G, which actually is the antiderivative of F, but we won't do it because it confuses students, increases and decreases. The area under G prime, which is the area under the F, is the amount that we increase or decrease. That means the second derivative of G would be the slopes of F. Now, the second derivative sign analysis we are used to, but we're going to bring back the third layer. It's actually the fourth layer. Who knows? The second derivative of G, which equals, stay locked in, fish, I know you got this, which equals the first derivative of F. If it's positive or negative, tells us if G prime, which equals F, increases or decreases. And guess who's back? Back again. Concavity's back. Tell your friend. Okay? And don't worry about it. You were fine with this already. Just like I never asked you questions about when is the dude moving on the x-axis is concavity positive. That doesn't make sense. When is the amount of heating oil in the tank concave down? That doesn't make sense. We're kind of back to unit 3 where we're just talking about graphs. And it's like, what's this graph look like? And when is it concave up its back? Okay? So, you notice the 2 big questions we're going to get to. Well, let's start with the 3 smaller questions. First one we kind of worked out, so get that really quickly. Go. Again, don't worry about the TDT. Pretend like the TDT is not even there. It's like I want to accumulate F, and this is the graph of F. Okay. We get 4 to 3 of F. It's the opposite of 3 to 4. From 3 to 4, we get 2. So this is -2. Great. Now, tiny question. See if you understand things. What is G prime of 3? Tell your neighbors, what's G prime of 3? It's a very tiny question, very simple question, but involves you understanding what we just talked about. Who's got it? Who's got it? No. Who's got it? Who's got it? Nice. Who's got it? Who's got it? Yes, you do. Who's got it? Who's got it? Who's got it? Yes. Who's got it? Who's got it? Oh, who's got it? No. Who's got it? 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 No. Who's got it? Who's got it? Who's got it? Yes. What is it? G prime of 3. Yes. Stool. Well, then how do you get it? Okay, great. It's a tiny question, but involves you understanding that G prime equals F. Oh, the graph of F is actually the graph of the derivative of G. G prime of 3 is F of 3. It's a tiny question, but you can find it. It's the Y value of F at 3. It's 2. Okay, next question, G double prime of 3. Put them up. Where's the fingers?
Hey, don't trick. That's a trick question.
Yeah, this is a trick question. Good. G double prime of 3 equals F prime of 3. the slope of f at 3, we remember all of the different things that derivatives mean. Instantaneous rate of change, slope of the tangent, slope at 3 is 0. Okay, great. Now, what's the max location and value of G? Yeah. What is the max location and value with justification? Five is location. Great. If you understand that this graph of f is actually the graph of a derivative, you should be looking at this graph like you look at your Y3 from your rates homework and from your rate quiz, like you look at the graph of V from last unit, like you look at the graph of V on the first question of your test. When is it positive? When is it negative? You're not looking at when it goes up and when it goes down. Not yet. We'll do that in a second. We're looking at G prime's sign. G prime is F. It's positive until 5. It is negative after 5. 5 has to be the location of max because the derivative is positive until then and negative after then without any other sign. G has to be increasing, then decreasing. G of 5 has to be the location of the max, the integral from 4 to 5 of F. 4 to 5 is just 1. No, that's the max value 1. What? How could that be a max value of 1? Well, team, you I like to say team. I used to be a coach. I probably will get back to coaching at some point when my kids are older. Look, the accumulation of G prime is 3, 4, 5, 6, 7. I go up 7. G of 5 is 1. You guys know what G of 0 is. You found it earlier. What was 3, 4, 5, 6, 7, 8? Sorry, this is 8. You guys knew from the previous page that G of 0 is negative 7. Oh, I started at negative 7. I increased 8. I then decreased 2. Your only candidates are your endpoints or this. Really, this is the only candidate because the function is increasing and decreasing. You have a sign analysis. You have what we've been doing. It's just one little thing where they throw an integral in your way, and you have to make a connection that this graph of f is actually the graph of a derivative. When is G concave up? Answer that. Some of you are going to be like, never. And of course, that's not right.
You know it? I know it.
Yes, Samuel. All right. We go back to our second derivative analysis. Our second derivative analysis is back We're not going to be asked about speed. We're back to asking about concavity. G is concave up when G prime is going up, when G double prime is positive. This is known to you. And then you're like, okay, when is G prime, which is actually the graph that's given to us. This is G prime going up 0 to 2. Okay, let's see if you can handle this all at once. Now, I change up letters. You got to be able to adjust and adapt. Ready? What is this the graph of? H. This is the graph of H. Okay. K is equal to the accumulation of H. Okay. That's how we're going to find all of these K values, this one and this one. It's finding the accumulation of H. But then we talk about the derivative of K. And what's the derivative of K? Thank you. Yo, this used to be a horrible lesson that students were like, woo! I've gotten so much better at teaching this lesson. Because I've been teaching it for 10 years. And like every year.
I've been learning it for like 30 minutes. I feel great.
Great, I know. Listen, it took 10 years of me improving things to get to where we are. -2 to -4 is the opposite of -4 to -2. This is just going to be a +1, so this answer is -1. I got to go all the way from -2 to 4. That stinks, but hopefully I'll use this value later. I got 1, 2, 3 down 1, 2. So this is a -2. And guess what? If you see the boxes, add up the boxes. I'm glad we're having fun. We got a base of 2, a height of 2. This is 2. This is 1.5. I start at -2. I subtract 2, I add 2, I add 1.5, I get 1.5. Okay, keep going. Copying things down doesn't help. K prime, it's K prime. Oh, but you're right. Stop saying that in front of me. It hurts my feelings.
I know that.
Yeah. All right, we got the first 4 done. The first 4 are easy. Next question. When does K have a point of inflection? Next question. When does K have a point of inflection? I'll come around and see how you guys are doing. When does K have a point of inflection? I kind of made it one triangle. 1, 2, 3, base of 1, 2, 3, height of -2. Oh, shoot, I screwed up. This is -3. My bad. So that is, no, 3, 2, 1, this is a half. My bad. Good? Okay, what x values does k have a point of inflection? When k double prime changes sign, when k prime changes direction, k will change concavity. You gotta be able to have any letter and its sign analysis. You can't have f's all the time. You can't have p's all the time. You can't have x's all the time. K double prime would equal h prime. K prime equals h. K prime will change directions when h changes directions. It changes directions here, here, and here. -3, 0, and 3. What is the min value of k? Go. Wally. He's 4, or he just turned 5. He's working on his wife. And this is Lola. This is the family motto. Be nice, be brave, be tough, work hard, and one extra is have fun. They didn't write that one down. They don't want you guys to have fun. Awkward.
Maybe you erased that one.
I did not erase that one. I hope this cost you a little. She wrote that. That was her. It's tough. Oh. That's funny. Okay. Do your homework. Later.
Oh, positive. And then,
I don't even need a pop on. I know. I'm like, Coach, the white shirt is hot. Like, I agree. Yeah. So my house is like still so you know what it is. Oh, would you just take, I would want to, you can go writing it down yourself.
Got it? Can do another one? Switch. There's a lot of there, exhale. Bros, I hope we understood things today. Appreciate it. Have a good one. Finish. From 4 to 6?
Yeah.
The base of 2, height of 2. It's just 2.
Oh, wait. I'm looking at the one going.
Oh, yeah, that's important. I know this line goes straight through, but remember, accumulate from the x-axis to the y values. You know, we got to go all the way to the y values.
Okay.
So don't think of this as one big triangle. It is this triangle with a positive area, and then this triangle with a negative accumulation.
So I was like, otherwise the whole thing would be negative, and I didn't think that was right.
Good.
Oh, it's backwards.
Yes. Yes. I mean, you can just think about taking the derivative, f prime, derivative of an integral, you know?
Yeah.
The derivative of an accumulation. There you go. Yep. Yep. But that's not it.
Yeah, and then from fourth.
Yep.
The max, that's when you gotta bring out all the other stuff. Positive until 2. And there's the 0. Oh, but is it, I guess.
Okay.
Am I not able to grab that quiz like day early so I don't hear?
We have to grade it, and no.
Not even the old quiz. Like,
No, the old quiz you can grade. The quiz we just took, we can't. Hello. Let me finish recording. F of 4 would have to be 1.5 because we decrease a half. This is the accumulations of my derivative. I go up 2 to 0. I go up 2 to 2. I go down a half to 1.5. And then I go up 2 more to get f of 6. F of 6 is 3.5. And that means f of 0, go back in time, we got negative 2. What's going on?
I'm just like confused with like where, cause I get B. I got that part.
Great.
The F of 2, that's when you're plugging that into there.
2 to 0. That's your starting point.
That's the starting point. And
Sure.
because you're going backwards and it's -2, and then because.
Yeah, I mean, it's just like, you're just accumulating, yes.
So for this one, for F of 3.
2 to 3. 2.
2.
You could either just say like, oh yeah, it's 2 because it starts with 0. You could say, oh, I'm adding 2. That's the accumulation of my derivative.
Oh, there we go. There was something,
It's all the same.
yeah, there was something for me that just wasn't quite clicking yet, and I was trying to figure out what it was.
So what is the max value?
Max value, hold on. That's not looking at the signs, that's looking at the numbers.
Sure. Yep.
It's not.
Your candidate.
It's not 3. Like, that's not the, it's the thing of, no, it's not 3.
Not K anymore.
G of
Not G anymore.
3 is equal
Nope. The endpoint.
Oh, shoot, I didn't.
So max is when F prime changes sign from positive to negative or an endpoint. Changes sign from positive to negative really just is at 3. We don't worry about 4 because 4 is the location of a min. We have our other endpoints. Think about what the areas are showing you. My function increases by 4, decreases by a half, but then increases by 2. So obviously this right endpoint is going to be the max. When is F concave up?
The F double prime is equal to E prime.
Yep. Hey, wait. Yep. No!
No, hold on.
Wait a sec.
Oh my
You're
God.
thinking it had to be positive. Well, all it has to do is increase. The slopes have to be positive. The values have to be increasing. All right, you all have plenty of practice on your homework. It's a great homework that I put together. It's different from past years.